Hello my darling senior one, I hope that you are fine. Today we have new lesson which is heat changes accompany chemical change. We will study heat changes accompany chemical changes. This part divided into two main parts. First we will study the standard heat of combustion, and in the second part we will study the standard heat of formation. First we will study the standard heat of combustion. Do you know what meant by combustion? The word combustion means the reaction between substance and oxygen. Why? To produce heat. So combustion means the reaction between substance and oxygen, substance plus oxygen, to produce what? To produce heat. Any organic substance. What meant by organic substance? Organic substance means it contain carbon. Organic substance, it must contain carbon. Like for example, CH4, organic substance. Organic substance also C2H4, C3H8, C5H12, all of them are organic compounds. This organic compound, when it combusted with oxygen, it will produce carbon dioxide and water vapor. So any substance of this, when it combusted with oxygen, it will produce carbon dioxide and also water vapor and also heat. So the combustion process releases heat. And when I say it releases heat, it means that it's exothermic process. And when I say exothermic process, delta H for this reaction will be negative. Delta H for this reaction will be negative. So all combustion equations are exothermic equations. Okay? And delta H of these reactions is negative. Delta H of this reaction is negative. Let me ask you a question. Do you know why during respiration process in exhalation, carbon dioxide and water vapor are produced from our body? Why that? What the main source of carbon dioxide and water vapor which are produced from our body? It reduced from the combustion of glucose, and the chemical formula of glucose is C6H12O6. When glucose is combusted inside our body with oxygen, it produces carbon dioxide and produce water vapor and produce heat. So delta H for this reaction is negative 2808 kJ per mole. Negative because it's exothermic reaction. I have to write the physical state right now. So glucose solid, oxygen gas, carbon dioxide gas, water vapor is gas. Now, do you remember the balancing? Let's remember balancing together from the first term. Balancing means making a number of atoms in reactant equal number of atoms in product. Now we want to make number of atoms in reactant here equal number of products, number of atoms in product here. So we have 6 carbon. We have 6 carbon atoms, but we get 1 only. So if we write 6 here, yes, we get 6 carbon. We balance the carbon. Let's move to hydrogen. We have 12 hydrogen atoms, but we get 2 hydrogen atoms only. So if we write 6 here, 6 times 2, 12. So we have 12 here, and also we have 12 here. 6 times 2, 12. Now let's count the number of oxygen in the product. Now we have 6 times 2 equal 12 oxygen here, 6 times 1 here, 6 oxygen here. So we have 12 oxygen here and 6 oxygen here. The sum of them are 18 oxygen. So we have 18 oxygen, but in reactant we have 6 here. If we write 6 here, 6 times 2 equal 12. 12 oxygen plus 6 oxygen also equal 18. So now we balance this equation. It is easy one. Okay? Thermochemical equation. You want to write it, you write the substance and add oxygen. It produces carbon dioxide and water vapor, and delta H will be negative. This is the general formula of any combustion equation. if we want to define now the standard heat of combustion, it's the quantity of heat released when 1 mole of substance. When 1 mole of substance is completely combusted in excess amount of oxygen. 1 mole of substance like that, we have only 1 mole of glucose. This glucose, 1 mole combusted in excess amount of what? Of oxygen to produce carbon dioxide, water vapor, and produce heat also.